What's up, guys? This is Walid. Today's problem is the changing the speed of light. So in this problem, we've got Roshana that's going in a car that has a length L, and Roshana throws a ball with a velocity of v. Okay, so they give us the L. Let me use the color. They give us the L, and they give us what's the speed of Roshana's car, or Roshana, and they give us the speed of the softball that she throws. Okay. So in the first question, we have Ed in here that's looking at her. He's standing still, not moving, and Roshana is moving on the car. So the question is, what does Ed measure the length of Roshana's flat car to be? Okay. So what they want us to do is going to be L is going to be equal to L0 divided by the Lorentz constant. But since the speed of light is so much bigger than the speed of Roshana's car, then the Lorentz transform will be equal to 1. You can do the calculation if you want to find it. 1 divided by square root of 1 minus, in my case it's 10.5 squared divided by 3 times 10 to the 8. The whole thing is square. When you do that, this is almost going to 0. So the Lorentz transform will be 1. And then when you do this equation, you plug it in, you'll get L is going to be equal to L original, which is in this case 6.8 meters for me. Okay, it's right there. Clean those stuff. This guy. So here it's 6.8 meters. And then the second question, what does Ed measure the velocity of the softball to be? Okay. So it's just what we did in physics 2111, the first physics, the mechanics. We just add both of them together. So we do 10.5 plus 10.8, velocity of the ball plus velocity of the car. So this will come up to be 21.3. Around 21.3. So in the second question, now let's suppose the speed of light suddenly changed from 3 times 10 to the 8 to 20 meters per second. Okay, so now the 20 meters per second is less than what we got in here. Okay, and that violates that everything is less, like nothing can move faster than the speed of light. So what we're going to do is we're going to use this equation. We're going to do, let's find first the Lorentz transform. This guy will 1 divided by 1 minus v squared divided by c squared, square root of that. So 1 divided by 1 minus 10.5 squared, 20 squared. And for that guy I got 1.17. Okay, so now the same as we did before for this one right here, we're going to do, because they want us to find the length, how does Ed see the car? So it's going to be L original divided by the Lorentz constant. So L original 6.8 divided by 1.17, which for me I got 5.78 meters. That's how Ed sees her car, Roshana's car. Okay. So what does Ed measure the velocity of the ball to be now? So the way to do this is v Ed to ball is going to be equal to v Ed to car plus v car to ball. Okay, and if you see that, that's how you know it's right, is you can cancel the ones in the middle. And the whole thing is divided by 1 minus v Ed to car times v car ball divided by c squared. Okay, and then for this one I got, what's the answer for this? Go. For this one I got 16.58. So let me put the whole thing in. So 10.8 plus 10.5, 1 minus 10.5 times 10.8 divided by 20 squared. And then for this you're going to get 16.59. Alright guys, so hope this helped. And oh, this is actually plus. This is a plus. Make sure it's a plus. Because when they're coming together, so the V in here, let me go back. The V in here and the car is going in the same direction, we add them together. If they're going apart, then we put minus on it. I'll see you guys. Thank you. Bye.